Hello, and welcome to the On-Premise IT Roundtable, the only podcast that dares to be both on topic and on location, no matter where that location might be. My name is Tom Hollingsworth, and I'm a part of Gestalt IT, and we have brought together some luminaries from the wireless networking industry to debate a premise, or topic, if you will, and see if we can get to the bottom of it. I'd like to take just a couple minutes to introduce everyone who's on the call with me today before we get to this episode's premise. Lee?
Hi, Tom. I'm Lee Badman. My Twitter handle is @WiredKnot, and you can find my blog at wiredknot.wordpress.com.
JD?
Hey, folks. Jonathan Davis, or JD here. You can find me on Twitter @subnetwork, and my blog is subnetwork.me.
Hi, my name's Avril, and my Twitter handle is @AvrilSorter USA. So it's just my name, USA. And I work as a technical trainer in the wireless field.
All right. And John.
Hey guys, John Deegan. Twitter is @Wi-Fi_John, and I've got a blog and a podcast. The podcast is more active. That's Spatial Streams Podcast, and the blog is wifijohn.com.
All right. Thank you all for joining us today. Let's get into today's premise. You probably know what wireless is. You've seen it everywhere. You probably use it every day. It's a technology that has become so ubiquitous that we don't even imagine what the world would be like without it. But the world has existed without Wi-Fi before. And notice that I'm saying Wi-Fi and not wireless, because while all Wi-Fi is wireless, not all wireless is Wi-Fi. There are a lot of technologies out there that are being used by equipment manufacturers and by service providers that aren't necessarily related to Wi-Fi. So today's premise is that Wi-Fi is not always the best wireless technology. Now, Lee, you and I were talking about this before the podcast started, and you're the one that came up with the premise for today's episode. So I kind of want to hear what you have to say about this. Why is it that Wi-Fi isn't always the best wireless technology?
I think that the reasons are probably more than I'll hit on, but whether we're talking about security, whether we're talking about topology, whether we're talking about RF propagation, the ability to penetrate through, walls and ceilings and floors and big buildings and all of that. Not all connectivity needs are the same. Not everything that gets connected has the same bandwidth requirements. It all doesn't need to go to the same network or same parts of the network. I'm dealing with to get more specific, I'm dealing with a building related project right now, building controls and sensors. It's kind of a research project. The easy way out is to take some legacy sensors, put on a USB dongle. It's a really ugly fit. Or you look at something else like LoRa, and for a number of reasons, it would just be much cleaner. It just goes on, but Wi-Fi has an appeal because it tends to be ubiquitous. So, you can't resist the siren song. It's cheap, it's there. But then when you start looking a little bit closer, you find it's not the best fit. And again, I mentioned a lot of the reasons, but any one of those is its own discussion. So I'll leave it there to kick us off.
I feel like that's a really good point, that there are a lot of the things that we do in technology kind of feel like they have a lot of inertia to it. We're going to use this because we've always used this. We're going to do it this way because we've always done it this way. And when people go back and take a look at it and go, wait, there's a really better, cleaner, faster, more efficient way to do this, everyone's like, well, it'll never work. Why? Well, because nobody's using it. So, let's take something that JD has actually written about for Gestalt IT quite a bit. Zigbee was it 802.15.4, which, by the way, if you're a fan of IEEE numbering, and I don't know who on this world would be, notice that that's not 802.11, which is Wi-Fi. 802.15 is a completely different wireless spec. So, JD, where would I use this, and why would I use it over Wi-Fi?
Well, so the thing to understand is 802.15.4 is kind of what a lot of those low power, non-Wi-Fi technologies are built on, right? So Zigbee, Thread, Lee mentioned, not Sigfox. What was it, Lee? LoRa, thank you. So a lot of these are built on this 802.15.4. And what's interesting, if you actually go look, 15.4 is really built for these low power personal area networks, really small networks, right? And we've kind of taken that technology and said, well, there's a lot more capability and there's a lot more we can do here. And so we've expanded that out, right? We generally, it uses frequencies. Some of it does use for Zigbee, as you mentioned, is really common in the 2.4 gigahertz space. But there's other frequencies that can be used there in the 400, 800, 900 megahertz spaces that provide us the ability to carry further distances, to penetrate buildings better, which is something Lee also brought up. But the other thing that they're generally built around is small amounts of data, right? So rather than having the super wide channel width in that 20 or 40 or 80 megahertz channel width, now we're looking at 2 megahertz or 300 or 600 kilohertz, right? So 0.3 megahertz or 0.6 megahertz. So these very narrow channel widths. And what that gains us is this super low noise floor, because one of the rules of physics in the universe and everything is that the more we listen to, the more noise we're going to hear. And so by listening to that very, very small channel width, our noise floor plummets, which means we have a much higher signal to noise ratio, and we can carry that, that signal miles, right? But we can only do that with small amounts of data. So really, to get to your question, when we're looking at Zigbee, what we're looking at is, as Lee alluded to, sensor data or on-off switches where we're trying to affect small amounts of change. We're not trying to download a YouTube video, or we're not trying to stream this podcast. We're trying to read a sensor, once a second or something along those lines, and maybe affect change, based on that. So it's really about what are the requirements. Like all of the things in IT, it's about establishing the requirements, and the requirements then dictate what wireless technologies fit, and whether that's Wi-Fi or something else.
I'd say that's probably pretty fair. And that's one of the reasons why this mentality that Lee talked about of, this is the way we've always done it. This is the most ubiquitous technology. We might as well use it. It kind of reminds me of people that, well, quite honestly, they still make proprietary power plugs for things when USB has been a standard for years. Now, granted, within USB, there's several standards that you can pick, whether it's a different kind of connector or whatever, but it shouldn't be this hard. We shouldn't have to keep making custom solutions to fix specific problems. So maybe a better question is, if all of these other technologies are so much better at specific applications, why can't we just improve the application that everybody's using to do this? Why can't we just make everybody all get along?
And where would the fun be in that?
Well, how so?
I mean, the analogy that pops in my head, right, is you're talking about, you could build a house just using a hammer and nails, but would you want to? Because it's not going to be the best built house. Sometimes you're going to need screws, you're going to need a saw to cut stuff. I mean, you can break stuff with a hammer, but it's going to look like, it's not going to look good. And so that's the beauty part of having all the different wireless technologies available to us. You can cover your phones with Wi-Fi, but to JD's point, you're going to want to use something more along the lines of whether it's LoRa or Zigbee or, Bluetooth for the various sensors you've got, depending on the requirements you are tackling. Something we've talked about a lot in the the world of Wi-Fi now is contact tracing, right? You could do contact tracing with Wi-Fi, but why would you want to? Because you're not going to get the accuracy that people are trying to get to. And I'm sure every one of us on this call has probably had a conversation about it or been asked about it. Could you? Yes, but why would you? You wouldn't recommend that. I mean, the first thing that most everybody's going to go to is, I would say Bluetooth. That's probably the most prevalent for things like location. But it all depends on what you're trying to do. there's different requirements and different parameters you're working in with each of these. Like you said, you've got 802.11 for Wi-Fi, you've got 802.15.4 for, the lower power, the LoRa, the Zigbee, and things like that. There's different rules for each. You don't want everything stepping on top of it. And I think the other benefit too of using, not necessarily Bluetooth, because it does sit on the 2.4 spectrum, but like some of these, the smaller channel widths, like JD just mentioned, you're segregating the traffic. You're dedicating that traffic is going to be able to perform better, and you don't have to share that space with, necessarily like, Joe trying to download YouTube in the waiting room of the hospital. You're ensuring that the cardiac or the whatever the meter is, the pump, that's got basically not necessarily dedicated, but it's not fighting for airtime with something that's certainly not, life or death. And I think that's important.
If I can jump in there real quick, I think one of the interesting points that comes from that also, and I love the actual using the tools, because that's one of the things one of the considerations maybe to take into mind here, is that one reason why I think a lot of people push a lot of sensor networks and other things into Wi-Fi where they may not be the best fit there is because they have the tools for Wi-Fi, right? And it's that as the phrasing goes, if all you have is a hammer, everything looks like a nail. And I think that's something that we see throughout a lot of the industry, where there are a lot of Wi-Fi connected systems that could be on Zigbee, that could be on some other technology, because it's easy to support them. If you look at Wi-Fi, we have the air checks, and we have the sidekicks, and we have all of these fantastic tools that give us visibility into what's happening in the RF and the spectrum, and we're able to capture packets and things along those lines. If you start trying to do that same thing in those other frequencies, it really falls apart quickly, and the level of tools for the cost, for similar costs that we have in Wi-Fi just doesn't exist, right? And so I think that's one of the holdups, maybe, Tom, to your question of, why can't we use more things? I think that's one of the reasons is we don't have that great tool set to apply in the same way that we do in Wi-Fi.
Yeah,
it's funny.
One
Go ahead,
more
Lee.
quick related point. I mean, we're kind of stuck with the physics of it all. Wi-Fi is 2.4 and 5 gig, and we have 6 gig coming. Even with 2.4, I probably am not going to be able to push that through an 8-plex apartment building, with just one AP down at the end or whatever. In that apartment building, if it's 8 apartments, there's a good chance it's 8 different Wi-Fi networks, 8 different potentially ISP providers. Very hard to put out like a sensor array and have it all go out, on a single, have it be manageable, because you're dealing with 8 different private networks. At the same time, I can go to a data closet. I can put in something like a, 800 meg LoRa gateway connected to an ISP. And that 800 meg is probably going to penetrate the walls pretty good to a sensor in each of those apartments. And that can be managed out of band, away from everybody's private Wi-Fi, and do just fine because of the physics of it, because of the characteristics of that particular radio band. So, wireless as a construct has been proven for, 100 years or better now as being useful, but we're really, as more and more things find their way to the generic network, find their way to the internet and the cloud, we're really just starting to discover how important the physics is. And Wi-Fi is limited when it comes to physics. It absolutely has its place for client access, and it goes as far as it goes. But again, it's just not the best band for penetration and all the other reasons we mentioned. So
I would like to jump in and give a different view, a different perspective, if I may, Lee. When you look at Wi-Fi and many of the standards, even Zigbee with the evolution of Thread, they've all moved to IP version 6 and up at the higher layers of the stack. So a lot of the network management stuff can therefore be universally applied across all of these different radio technologies, as long as they've moved to an IP version 6. You've got some technologies like wireless HART that are going to be somewhat limited because of their legacy stack. But then if you look at it and you look at the Wi-Fi standards, right? Well, let me back up a bit. Things like LoRa and Zigbee were defined because they filled a niche, a really valuable niche, and there was a business case for it and people would fund it. What you're now seeing in the Wi-Fi standards is that they have gone well beyond the 2.4 and the 5 and the 6 gig. You've got WiLo, which is the sub 1 gigahertz, which extends the range, into the kilometer aspects, right? So we're well out of the cell coverage limitations that you historically think about Wi-Fi. You've also got the 60 gigahertz band, which has provided a huge opportunity for connectivity of devices. And so if we just say Wi-Fi is just the 2.4 and 5, we're limiting our view of what the Wi-Fi standards is. And Wi-Fi over time, they've been adopting, as the business needs and the IoT's market's growing, they said, well, we too can do this. I'm not saying it's a better technology. I'm not arguing the business case. I'm just arguing the technology perspective. From a technology perspective, they've done many of the same things. So for instance, JD, you mentioned that Zigbee in the 2.4 uses a 2 megahertz channel. 802.1x, if you look at a resource unit, which is 26 subcarriers, that's 2 megahertz. So they can get to the same, almost the same RF attributes right across the unlicensed band. And so from my perspective, I think if we ignore the business case, does anybody want to build this product? Is it going to replace, if from a technology perspective, is equivalent and can provide basically equivalent services and capabilities that these other technologies can deliver? Like you're starting to see really close location, much smaller coming into the latest specifications. To me, the only difference, and it comes back to your point, Lee, which is it is down to a physical aspect. I think the limiting thing of Wi-Fi is that it's only in the unlicensed spectrum. And I think, therefore, it can't be everything. I mean, you can turn it into everything because, those standards are being written. And I think it can do everything as long as you're in the unlicensed band. But the minute you want to go into the licensed band, it just is just not there. No one's made it there. But that would be my major difference between them.
I think also, Averill just sparked my, kind of a point of reference in my mind. I think also some of what we're talking about is also falls along the lines of consumer versus enterprise. You can do a lot with Wi-Fi at home that I don't think you can do in the enterprise, where you're managing large buildings. Again, your whole house is going to be the same network, your sensors, you can kind of do whatever you want. You get into a campus or a mall or a hospital or whatever, where you've got these massive networks. The fundamental constructs change, not just for the physical attributes of whatever you're trying to do, from a signaling perspective, but also the logical topologies that you're playing on as well. And, at least in my world, that's a lot of, where things kind of divvy up to as well. Is this a consumer or an enterprise thing? I manage an enterprise. A lot of consumer stuff just doesn't fit well.
And that's one of the things. Oh, go ahead, JD.
Well, I was going to say, it's funny you say that, Lee, because when we often think about kind of the beginnings of Wi-Fi and enterprise, so often it was, dark IT. It was someone going, well, my work laptop has this Intel Centrino, chipset, and I know that I can get on my Wi-Fi at home, but we don't have that at work. So I'm going to go buy a Linksys WRT or, whatever the, even prior to that, come to think of it, and I'm going to go into the office and I'm going to plug it in. Right. And a lot of times commercial or corporate enterprise wireless actually came out of, we have to have a clear managed solution because our users are demanding it, right? And kind of going back, if we swing that into the more of the Wi-Fi or the wireless, the non-Wi-Fi, there's really something really interesting going on right now with Apple and Zigbee and a lot of organizations have created this connected home consortium, I guess, and it's going to be really interesting to see what comes out of that, because they have tenants that answer a lot of the problems that kind of come with a lot of those other wireless solutions, right? Security and things along those lines. And I think as they kind of release that kind of back into the community, I think we'll probably see that those same technologies land in our corporate and enterprise networks, because if for no other reason, because of scale, because they can produce the chipsets and they can produce the drivers at scale for the stuff at home, and that's what will lead it into the corporate enterprise.
I think that's what we're seeing a lot of, or at least I know I've been seeing a lot of that too, is like JD said, like there's a lot of consumer devices that are making their way into the enterprise, and that's driving a lot. But there's certainly consumer devices that you don't want on your enterprise. I know a lot of corporate companies don't let things like, say, a Sonos onto the network, or they didn't because of concerns or what have you. I wanted to say one thing real quick. We're all talking a lot about the unlicensed, and I think we sort of touched on it, I can't remember who, but somebody started to sort of veer into the licensed side of it. And that's something else that we need to remember is there's that whole license spectrum, cellular, if you will, that sometimes is better than Wi-Fi for certain applications. I mean, I've looked at projects where, people were asking for, connectivity on, a vehicle, not necessarily going at 60 miles an hour, but a vehicle, and they wanted Wi-Fi coverage. And we're like, no, because it's not going to work well. But if you use cellular and you've got coverage, that's probably your best bet. So it does depend, to beat up on that tagline, what you're doing and where. But the other part, and I think Lee was sort of going there, and I think Avril may have been as well, we're dealing with a limited amount of bandwidth, right? And whether it's 2.4 and 5, or we get into 6 and 60 and all the others, at the end of the day, if you've got a really big chunk of spectrum available and it's across 18 different technologies, use it. Because we've seen, especially with the explosion of IoT, if there's bandwidth out there to use, something will use it. And if you're not using it, then you've got, you're missing out. And it's just spread the traffic out, spread the devices out, because it's going to help everybody have a better experience. Because at the end of the day, even though I always say plug things in when you can, especially the IoT devices that aren't moving, people want wireless because everybody inherently thinks it's easy. They always tell you it's easy. We just do it at home. We plug in something and it works. The reality is the physics aren't always as easy as they would like us to believe. But use what you can, use whatever's available. And that includes the idea of the license stuff with, whether it's, the cellular networks, or now with CBRS becoming a big thing. Use whatever spectrum you can get, because, it's a finite resource, really.
John, I think you bring up a great point there. For a long time, many of us called ourselves wireless engineers, but the reality is we're Wi-Fi engineers. The majority of us have been using Wi-Fi technologies and Wi-Fi technologies only. I believe that over the next several years, we're going to see a demand placed on us to manage a lot more than Wi-Fi. And I think we're also going to see more use cases that were previously always going to be Wi-Fi, maybe make a jump to something else, right? So if we use CBRS or unlicensed LTE in the rest of the world as an example, you mentioned the fast roam times. Well, the other place that we have fast roam times and we need that really big coverage is warehouses, right? We need large cells, we need super fast roam times. And that may be one of those situations where in 3 to 5 years on large warehouse installs, we never reach for wireless. We instead reach for a CBRS, solution or an unlicensed LTE solution. I can think of a lot of warehouses that I've designed in the past where the warehouse, because it was so large, I actually had more access points than I had client devices. And that's not that uncommon, right? Which is crazy when you think about it. I mean, ultimately, to have that much of an outlay and that much spend for the infrastructure when the device count is even smaller than the number of access points. With technologies like CBRS and some of those others, we may actually be at a point in the very near future where we can make a decision and go, actually, the say 4-to-1 replacement. I can put in one CBRS AP that covers the what I would normally be covering with 4 or 6 or even 8 wireless APs, and it begins making more sense. And also, I deal with one of the biggest headaches in warehouses, and that's the roaming issue, right? So I think the demands that are going to be put on us over the next several years is going to be acceptance and use of more technologies other than Wi-Fi.
Can I know, Lee, you might want to jump in. I just want to build on what JD was saying, if you would forgive me, Lee. If we take what you're saying, and my hope is that if we look out 10, 15 years, that we get to a point where we say, this is the spectrum we have. We've moved capabilities towards the edge. We talk about cloud edge and capabilities and connectivity with IP version 6, that we end up with just spectrum that we can use in our businesses or in homes. And then we choose the best spectrum, the best way of transmitting over that spectrum, whether that's a technology or an air interface, but we say this is the best way for that type of service. So if I'm running multiple services, I might want to run them on different frequencies with different air interfaces. And that would be my dream for the future, is that we move away from these technologies and just say there is air interfaces and there's radios, and we just use the best one. And then our jobs will become much more of the radio people that understand, if you're operating on this frequency or this antenna, or you want this kind of coverage, then our expertise that we inherently have with Wi-Fi gets extended out to these other bands, other technologies, and we just become the wireless gurus that can work in this huge, huge world of radio. That's my vision, building on what you're saying. I hope that's where we go. Sorry, Lee.
I'm glad you said that, actually, Averill, because that would be wonderful if, as long as the client device manufacturers, and this kind of gets back to what I was saying about the home versus enterprise, as long as they don't dump too much special sauce on all of these products. We have the standards, and that goes back to the original question, Tom. Why don't we just make 802.11 clients and all that better? The client space is so fragmented with special sauce. You go and buy any of the home kit, any of the, home oriented product sets, and yeah, they're based on 802.11, where they're Wi-Fi, but then they've got all kinds of junk dumped on them. They need some special little casting capability. They need some little weird UPnP thing. They need to all be on a single class C network sort of stuff, and to run this one oddball protocol that doesn't scale. And if you don't do those things, they don't work. So 802.11 client space kind of got run amok with all of this weird little every man for himself, despite the promise of interoperability from the Wi-Fi Alliance. To me, that is just such an offensive drum that they beat, because it just really is not the case, or they don't go far enough for interoperability. So back to Averill's point, boy, I do hope that one day we're called upon to say, pick me the best radio technology. And maybe by then, in a perfect world, the client device makers will have learned that you can't junk it all up with this proprietary crap. So you strip away all of the interoperability, even though everybody's using the same standard. They've coated it with so much junk that product A can't work with product B.
This comes back to Tom's question when you say, why can't they all work together, right?
So I think actually the point there, as we've developed this discussion, it kind of made me realize something. We've seen this in the chipset market for a long time. We used to have purpose-built chips, and then Intel came along and said, well, I'm going to build one big chip that does everything. And we fell into that bandwagon, and we had the big chip that did everything, and sometimes we had to do some workarounds to make the big chip do something different or better. And we got away from the fact of realizing that sometimes building a chip to do something very specific is still important. Could you imagine what a cell phone would look like if you had to put an Intel chip in it? And when I say Intel chip, I don't mean the ones they make for cell phones. I'm talking about a Pentium 2, which, as I recall, it was about the same size as an iPhone. So I think the point that we brought up in maybe the summary here is that you need to know the tools that you have to use. To John's earlier analogy, you can build a house with hammer and nails, but I don't know any house carpenters that only have hammers and nails in their toolbox. They know the tools, they know the applications. They don't use screwdrivers as chisels. They have what they need to accomplish the goals that they're looking for. So when you're ready to sit down and you're ready to make the decision about what you want to do and how you want to do something, instead of just thinking, oh, we'll use Wi-Fi, do the work. Figure out what it is you can use to get the job done. You may find out that there's a better, cheaper, faster protocol. You may find out that you have been completely missing something that would be a much better application. And when you learn the tools, you can build some amazing things. That should just about do it for this episode of the On-Premise IT Roundtable. I want to thank our guests for joining us today. If you'd like to check out more podcasts like this, please head over to our website, gestaltit.com/podcast. You'll always find the latest episode there. You can also subscribe to our podcast in your favorite podcast application of choice, or you can check us out on iTunes. If you do check us out on iTunes and subscribe there, do us a favor, leave a rating, leave a review, help somebody else find the On-Premise IT Roundtable. That way our audience can grow and we can find some more great premises to debate with you. So for Tom Hollingsworth, for our great guests, and for the rest of the Gestalt IT family, we bid you a fond adieu. Take care out there.